Okay guys, it's 6:30 on Monday the 28th. It's very hot and humid in Pittsburgh. I'm not on call. I'm not the backup guy on call. I'm the backup guy. One of my customers just called. He said his chiller is down, so it's my account. I'm gonna take care of it. So let's see what we can find, guys. I just know it's very hot out. Got to get it cooling. So, all right, let's see what we find. Okay guys, I just got here on site. 92.2 degrees Fahrenheit, 44% humidity. Let's see, dry bulb, wet bulb here. Wet bulb. Okay, okay. Okay, we got a little breeze going. Not too bad, not too bad. As soon as I pull up, I just parked over here because nobody's at the facility at this time. Now, our chiller is not chilling. It's just sitting here. I don't know if we got power. I don't know what's going on at this time. I just know it's not running, and my customer called me a couple hours ago and just come out to take a look. All right, so basically the chiller. You have a compressor, you have condenser fan motors on top, you have a condenser coil up underneath, and I cleaned it not too long ago. And this little device down here, that is a bundle. Okay, it's the chiller bundle itself. I guess you can call it an evaporator. Basically, inside of here, they have a sensor, okay, detects that water temperature, that tells your chiller, hey, do we need to cool this down or not? Also, there is a flow switch. Okay, so if our circulator pump shuts down, we'll have, well, no flow. There's a paddle type in here. This is McDonnell Miller. It'll have a paddle inside here sensing flow if your circulator is running or not. That's one of the worst things you could do for a chiller, is basically running it dry or, well, running it with no flow. Okay, so let me see, that's dripping away. So, and it's just water in here. Okay, I wonder if we're a little bit low on water. Don't know at this time. I just got here, like I said. But I want to check the basics because it was really hot out here. I'm going to check to make sure we're not tripped on something at this time. So let me go grab my gloves and a couple tools, and we'll pop this door and take a look. I popped my door open real quick while I was watching what I was recording, and I was a little disturbed. This is a first. Okay, first thing, you have a resettable breaker inside of here. Okay, that's on. Then you have the little circuit breaker fuse for low voltage. Okay, I was just glancing around, just taking a little peek around, and then I think something might have nibbled away at a wire or two and possibly have shorted something out. Sorry if that disgusts you guys, but whew, he didn't feel a thing. Trust me, he didn't feel a thing. So, okay, let me shut down this chiller just to be safe. Let me find the main power supply inside, and I'm gonna open that up, make sure he didn't nibble away. There might be a complete mice nest inside there. So, okay, guys, and yeah, you got your little mud wasps and nests and stuff, and spider nests. So, yeah, let me shut this down just to be safe so nothing can arc out at me at this time, and we'll go from there. Okay guys, I pulled off a couple panels. I verified we had 3 legs of power inside, 460 volt, 3-phase. Okay, so that's good. I had an alarm on my little circuit board. I shut off the main control switch. So I got that dead mouse right there, which is disgusting. I pulled all these off, so this is, I'm gonna remove this cover. Now I don't think there's anything alive behind here, but I jump back. I'm just assuming he was gnawing away at something and shorted something out. I'm gonna double check power, make sure we're all good down in there, but yeah, he's stuck in there. Yeah, oh man, it's a shame. What a way to die. He didn't feel a thing. So he probably shorted out something, but it did not blow the fuse, so. All right, hopefully he didn't short the board or anything. Okay, let's go from here. Okay, guys, I was wondering why there was hornets and yellow jackets around me. All right, I used my spray. Okay, some nuke. Oh, okay, I gotta get him too. Okay, I'm always on their list. For some reason, they love me. I think it's my blood type O. I think that's the problem. Well, anyways, they made a nice nest up inside here. I probably should have left it alone, but they just kept getting around me. So anyways, I had residual power inside the electrical pecker head on the compressor. Yeah, that's the term, pecker head, right here, the electrical cover. So that mouse had gnawed its way in through a crankcase heater wire, which would be higher voltage. Most likely 277 volt, probably 460 volt. Either way, yeah, he didn't feel a thing. So it probably threw something off, maybe with the circuit board. I just crossing my fingers, I just got to reset power and control voltage, and it should come back online after when I pull that mouse out of there, which I'm going to use a high-tech stick, and I'm going to shove it out of there, and then I'm going to, after that, inspect that wire and reset it, and then run from the Hornets. So, okay, guys, life of heating and air tech, commercial and industrial. It's always something, so it's always exciting. Okay, guys, after I used that high-tech stick I picked up at the local supply house, the Woods. Okay, so I got that out of there, and if you could see, bare wire. Okay, bare wire. It's going to short to ground. That's what happened. The mount. Let me get away from this yellow jacket. Get away. Go. Anyways, okay, so that was the path of least resistance, was the mouse shorting to ground. It didn't trip the three-phase breaker for some reason, but it probably caused a little interference with the circuit board, and hopefully, crossing my fingers, just shut down power, tape up that wire, turn it back online, and it should fire up. So hopefully, simple fix. So never know what to expect in this field, people. Never know. Okay, guys, so I got that mouse out of there. I ran those zip ties up on there. I got to cut those off still. I taped up the wires, so that's done. Now I'm going to go ahead and turn on our breakers here, all right? Let me flip down my arc flash helmet, okay? Turn that on. Turn that on. Now, I got to turn on the main breaker inside. I'm going to do a patent pending on this thing, so don't try to copy this, okay? Now, it was a little bit odd that that dead mouse did not short anything else out. Typically, that would trip a breaker or blow fuses. There's no real fuses inside this unit. There is a small circuit breaker inside here, and then there's fuses inside of a panel inside. But it was an alarm. I'm thinking there might be something else to this, but I'm going to flip power on, and then we'll see if it fires up and go from there. So let's fire it up. Okay, got those breakers on. Oop. Lights on. Motion sensor. Pump. Okay, pump. All right. Okay, probably going to be a time delay here, so bear with me. All right, guys, just kicked on literally a second ago. Uh-oh. All right. On a hot day like this, if that second fan don't kick on, it's going to trip off on a high head. Unless we got a bad fan cycling control. Let me wait and see what happens. If it don't kick on, I'm going to check out that fan and the fan cycling control if there is one. Getting pretty hot. Come on, baby, kick on. And we might have a bad fan motor. That might be the whole culprit. It was tripping out on high pressure, and it was going into an alarm, and maybe that mouse didn't cause it. Either way, we had to get that mouse out of there. We had to fix that wire. It was going to short out eventually. It's getting hot, people. Oh, she's getting real hot. Yeah, let me shut this down. This fan should be kicking on by now. Just have a suspicion, guys. We either got an open motor or maybe a wire burned off. By the looks of all this rust, might be an original motor. Power's off, everything's dead. Oh. Bad bearings. Bad bearings, it's got an open winding, almost guarantee it. Let me grab my camera. Okay, all right. Bad bearings. Typically what goes on is it bounces back and forth between those bearings, hits the stator and opens a winding, or could short the ground. So I'm gonna go ahead, well, I can go ahead and check back at the contactor. But end result, I can't get a fan motor tonight. And this could be running by tomorrow morning, so it's okay. Just a heads up, little tech tip. You see this blade? I don't care how much heat and PB blaster you put on this, don't do it. Replace the blade. Blade, a lot of times the rain shield comes with them. 3-phase motor, so there is no capacitor. But I'm gonna check this out and spray it down with some PB blaster on the bolts to take this off. But I'm gonna gather this motor model serial number information and call carrier tomorrow morning, everybody. So, okay guys. That's what it is, bad bearings, it just wear and tear. Noticing something else too. If you guys can see right there, notice how high that blade is and where that shaft is. That collar's at the very top. This one's down. Like, look, it's under this. It's gonna kind of recirculate. Interesting. Okay, wonder what happened there. Okay, all right, so I'm gonna open this out real quick. Yeah. All right, guys. I don't want to have to mess around with that tomorrow morning, okay? So, all right, and what I did was, let me set this aside. All right, so, I don't like to leave things where people can get lit up if somebody should accidentally turn the power on, okay? Just put some type of wire connector, zip tie it up out of the way. Just something in case somebody else comes in here so they don't walk in blind. So now generally with these motors, you can see there's so many different wires. This is going to be a dual voltage motor most likely. So you just have to actually read the numbers. It'll say whatever P6, P9, P2, T1, T2. It'll say different ones. And a lot of times it'll show, I do this carefully so I don't drop this back in a condenser. It would not, there we go. Okay, I know it's kind of faded, but it'll actually tell you how to wire if it's low voltage or high voltage. Actually, I'm reading it upside down. That's how faded it is. So, but yeah, it's really not too bad. Not too bad. So I'm going to take this motor with me tomorrow morning, stop by that supply house, and they should have a new motor. And like I said, get a new blade, rain shield, anything you can. You don't want to struggle. It's honestly, the amount of time wasted trying to take that blade off, it's not worth it. You're probably going to damage it anyways, and it's going to throw the balance off, and there goes your bearings again. So start new. Do a shotgun effect, replace it all. Trust me, save time. Okay, guys, I gotta wrap it up here, and I gotta notify the customer every little detail here. Ooh, and I'm gonna open this out for you guys too. Let me just do that real quick, and I'll end this video. Okay, guys, I'm starting to lose daylight, and I have to be on a job site by 5:30, 6 a.m. tomorrow morning, so I gotta get started. It's a medical facility. Gotta get there early. Anyways, want to show you guys this. I was trying to prove a point that it's open. Probably not grounded, because it would have most likely tripped the breaker or a fuse, but it's weird. But I'm thinking everything's open. So we got our main 3 legs here, okay? The main 3 that I clipped the wires from. Make sure they're not touching one another. Set your voltmeter to ohms, okay? I got alligator clips here. This is nicer sometimes than these little probes, because it's tough to hold these on there, okay? So I'm gonna grab onto one leg, and I'm gonna grab onto another leg. We should be reading an ohm value, which we do not, okay? We do not, okay? And you can tell that they are touching, so we'll grab this next one here. We got nothing. Then we'll go between that peach color one and the blue one here, okay? Or this, well, the orange blue. My wife will just laugh and say, oh, you're colorblind. So, okay, so that's definitely open. Now let's check the ground. Just grab the metal casing or a ground screw. I'm gonna just grab the blade, okay? Heard a noise. Okay. Okay. Oh, what's that? Oh, we're grounded. We are ground. Maybe when I was jostling this thing around, maybe it suddenly did ground. Okay, well anyways, that's grounded. So if you're reading a resistance between ground and the copper, that means that copper is doing this. It's grounded, people. Okay, that'll blow a fuse, trip a breaker, go poof. Okay, it's scary. It's a scary noise. Reading open, it means those windings, it's not coiled together to start that motor in that correct rotation. So it's open. You should be reading a resistance. If it's three-phase, they should be identical between all three. So, okay, guys, remember that. Also, maintenance-wise on this motor, you can't do anything. I mean, you can check connections, amp draw, rotation. You cannot grease the bearings. You cannot oil them. They are a pre-sealed from the factory. That's it. So they run whatever this chiller, who knows, is, I don't even know, 15, 20 years, maybe older. Might be original motor, I don't know. So, but there you go, guys. Hope you're learning. If you like what you see, give me a thumbs up. So if you want to see more. So thank you very much. Hope you're learning. Okay, guys, guess who's back with a new motor, blade, and a contactor. Okay, I'm doing this in the back of my van because I don't have to do it inside the unit this time. Okay, so this is high voltage. Okay, let me see if I can get this in the shot. Okay, it tells you exactly how to wire it. Set this here. Okay, now one thing I just noticed, it's telling me for P6 white, P4 white, and P5 white. Insulate each lead separately. That shows a wire nut, wire nut, wire nut. Okay, they're together, but they're separate. Well, we go to our old motor. It's the exact same setup, the exact same. Somebody had these wired all together, okay? One wire nut, all three whites. So I don't know who did it, but it ran for a while. So I guess just doesn't really matter, but it's just little things I notice. Always try to pay attention to detail, people. Okay, and I always like to use electrical tape after my wire nuts and just make things a little bit neater and organized. And so here are my main leads are going to go to, we got a T3, okay? This should be T1, T1, and T2. So that's your 3 legs of power. Now I'm going to set up my voltmeter and I'm going to show you guys just to check your own value real quick. Okay, guys, so we got my 3 legs. They should be pretty much dead on, okay, if I check ohm value between the two, or all of them. So there's we're gonna go T1 to T2, okay, 8.1. Let's go T2 to T3, 8.1, 8.0. Now we'll go T1 to T3. Sometimes it's not grabbing just perfect, but it's grabbing to here and there. Okay, but you get what I'm saying. They'll be pretty much equal. So there could be a little corrosion on these two. Now we check it to ground as well. So I'm gonna grab just right onto, you can grab the ground lug or you can grab onto the case or the shaft. Okay, not touching ground. Try to separate these, I'm sorry. Not touching ground. Not grounded. Not grounded. Okay, now if it were touching ground, we would see something like this where it's reading that. But you just, end result, you want to see OL. So Okay guys, I'm gonna hook this up. I gotta make sure rotation's correct. If the rotation is backwards with 3-phase, all you gotta do, switch any of the 2 leads. Doesn't matter, it'll switch it over, reverse rotation. We are rolling. Music to my ears. Okay, while that's cooling, I had to clean up. Change the contactor too. Always change a contactor when you change motors. Say that motor costs $1,000. This contactor might be under $100. Who knows? I can't give the exact amount on that, but you change it. Just like you put new tires on your vehicle, get the alignment, okay? So. All right, guys, you know what? I'll show you what exactly this chiller does, because some people wonder what that does. You got the condenser, compressor, 2 condenser fans outside, and underneath you have that barrel, okay? That's your heat exchanger, evaporator, whatever you want to call it. It runs inside to multiple units in this facility, okay? Multiple units, and instead of running a condenser to each and every air conditioner per room, that's your condenser, one giant condenser. It chills, a big loop goes around, goes into a chilled water coil. Inside, there's a thermostat tied into a fan motor. Then it says, hey, do we need cooling? That chiller's already up and running. It's circulating chilled water through those coils. Then your thermostat is controlling just your fan, okay, on this particular system. So, but I'll show you inside real quick. Okay, guys, so there's multiple fan coil units here. Let's see if we can turn this on. Go. Ooh, that's nice and good. That feels good, actually. Let's see, let's set this up. Okay, so this is your fan coil. The chilled water comes through here all the time in the summertime. Wintertime, it switches over a separate valve for a boiler system, and then boiler hot water comes through here. Then the fan goes across when the thermostat's calling for it. So this chilled water coil, it sweats, it gets extremely cold, it drips into this drain pan and runs down the drain through the side over here. Okay, you got your drain pan, drips into there and goes out the building. Okay, you got your fan motor here. Yes, these units are very old. Here's what it is: sucks your return off the floor, goes in through this filter that I strategically placed here. Then goes up through the back of the coil with the fan, and then comes out the top, and just basically creates a big vortex in the room. So, okay, guys, hope you're learning. There's always numerous ways to heat and cool a facility, a building, a house, anything. So, hope you guys are learning. HVAC explained.